Hello everybody, this is Chad Williams, and today we're going to do the Computer Lab 2 in R. In this, basically, we're going to use a Survivor data set, so the Survivor show, and then we have one of two research questions you can choose from, and we're going to do plot, so a scatter plot with a regression line, as well as a correlation and a regression itself. Make sure you've downloaded the dataset from Brightspaces and the assignment as well. If we look at the assignment really quickly, like I said, we have two different research questions here, so make sure to read these thoroughly. The first one is just looking at whether the viewership in the premiere episode of each season is related to the viewership in the finale of each season. And the research question 2 is whether the mean viewership of each season changes across the seasons. So there's about 41, I think, Survivor seasons now. So have they stayed the same viewership wise, or do they increase or decrease across those seasons? So we have all our instructions here, but in step 1, we're just going to load our data generally. So we did that last time, shouldn't be a problem here either. And we just want you to indicate which research question you followed. So again, you only need to choose one of these two and follow along with that. Then we're going to plot our data on a scatter plot with a regression line. And then from that, we just want you to actually tell us what you think without doing any statistical tests. We don't know the correlations. We don't know any of that kind of stuff. What do you think? What does this data look like? Does it look like there's a relationship? And so forth. Then we're going to actually compute a correlation. And we're going to get you to tell us a bit about that correlation as well. And then we are going to do a regression here and then tell us a bit about that regression as well. Perfect. So let's get to R and doing it. So the first thing we need to do is show R where our data is. So we're going to go to the top and there's a tab called Session. And we're going to go to Set Working Directory and then choose our directory. Now we have to find our survivor.csv file, and here it is in my folder. So I'm going to hit Open. And you saw a few other things in there too, but that's okay. I like to always comment my code, so we're going to start off with loading data, so I might as well put a comment there of load data, and we're going to call it survivor underscore data. Of course, you can change this to whatever you like, but you need to be consistent throughout your own script. So we're going to use read.csv and then survivor.csv as well. So I'll close that gap. If we run this, suddenly we get a data set with 38 rows and 19 variables. Now we've left all these other variables in here in case you're interested in exploring more, but we're only going to use up to 4 of them. So we have 2 different columns for each of the research questions. First one is going to include the viewer's premiere and viewer's finale, and the second one is going to include the season over here, and then viewers mean over here. Of course, you can explore more if you like. So this is the full data set that you should have as well. So what we're going to do here together will include all of the answers for the assignment as well. So there we go. The first thing we want to do is plot our data. There's different ways we can plot, but the most common way is using a package called ggplot2. Now, packages are essentially a bundle of functions, and I'll put a link in the top here about a video I made about packages. So what we need to do next is load our library ggplot2. So I'm going to put load library as my comment. Then to load a library, we go library, and then in brackets, what that library that we want is called. So ggplot2 is what we're looking for here. Now there's a slight change here. If you've never actually used ggplot2, before you can load it, you need to install it. So in your console, you go install.packages, and then in this, and you see it down here, in this you put ggplot2 but in brackets. So I use single brackets, but you can use double brackets. If you hit enter, it's going to download stuff and do pretty much install it for you, and then you can load it. So when you use a package, you have to install it once and then never again, but then you load it in this library each time. Now you can install it again in the future and it'll update it. Perfect. So now I'm going to actually load my library here. So there we go. And anytime you see me just highlighting something and something runs, I'm basically hitting this button, but I have a keyboard shortcut for it. So how do we use ggplot to create these plots? Now, it's not entirely intuitive, but I'm going to start off with rq1 underscore plot. So I'm actually going to put this plot into a variable, just like our data is in this survivor data variable. We're going to actually have an rq1 plot later. Now rq1 stands for research question 1. So that's the one where we're correlating the premiere viewership to the finale viewership. I'm going to do both research questions simultaneously here. So I'm going to do the plot for research question 1, then 2, and so forth. Now how this works is we're going to use the function ggplot. Okay, even though the package is called ggplot2, our function is still just called ggplot. Now within this function, we need another function called AES here. I believe it stands for aesthetic, but I'm not entirely sure. So I'm going to go AES here. And then what we're going to do is we're going to say what our X variable is. So for us, it's going to be viewers, premiere. And then so comma there, then what our Y variable is. So it's viewers, finale. Okay. So you'll notice I don't have the survivor data name in there anywhere. Okay. So after this aesthetic, what we're going to do is we're going to put a comma and we're going to say data equals survivor underscore data. So what these are just our column names. So for example, survivor premiere is right there. Viewers premiere is right there. And so we're just saying what columns to look at in this aesthetic here. But then after the aesthetic, we're going to have this data argument as well, saying what data set to look at as well. So I'm going to collapse this all back onto one line to make it a little bit easier to read. So when I save it to this variable, we get this new variable here, but it doesn't actually plot anything. So to actually plot it, we actually call the variable as well. So you see I could just write it in down here if you want, or just run that variable name. So rq1 underscore plot. And so that plots it on the right here. But you'll notice there's not much there. Now it has already prepared the plot. So you see our x-axis and y-axis titles reflect the x and y we inserted here, but there's not much. So what we're going to do at the end of this is we're going to put a plus sign. So we're going to add something to this plot. And then we're going to use something called geom underscore point. Okay, now this is going to add points to our data. So it's going to add the actual scatter. So if I run that and then again run this, there's our scatter points. Great. Not so bad, not so hard. There's still a bit that we're missing. So first off is the regression line. So to get a regression line, we're going to again add a plus sign, then use a new line and go geom underscore smooth. Now this we have to add a bit of stuff in here. What we need is the method equals lm, which is a linear model. And then we're going to do a couple other aesthetic things. So I'm going to put se equals false. So it plots a error bar or error band around the regression line, but we don't want that for this case. And then col equals blue. So that's just the color of the regression line. You can change that or not include it. That's up to you. So if I run this now, we get this. So we get our scatter plot and we have a regression line there. And you'll notice it even stops at our last data points, which is great. And that's what we want. Now you can stop here and start answering the questions and move forward. But in case you want a little bit more of a professional look, and for all my professional manuscripts, I use ggplot2 and code very similar to this. I'm going to make this look a little bit better, but you can definitely skip ahead from here on. So the next thing I'm going to do is I'm going to add another plus sign over here, and I'm going to go theme underscores classic. Now by doing that, I'm going to remove this gray background. Now lots of people actually like this gray background, so if you do, then feel free to leave it. I personally don't, because it's not APA style. So if I run that now, it looks like this. Perfect. The last thing I'm going to change is just this x and y variable. Again, this is going a little bit further than we need to, but maybe you want to learn this stuff. So my X variable is going to be premiere viewership. Ooh. So you'll see I put another plus sign, and then now I got X lab, and then in the X label, I have the actual label I'm going to want. I'm going to go plus and then go Y lab, and it's going to be the same thing, but finale viewership. Okay, and if we run all of that now, what we get is this RQ1 variable that gives us our scatter plot with a regression line. We do see some sort of looking like outlier up there with proper X and Y labels. Great. You can take this even further and make it, even better, but we're going to stop there. So this is plotting, and I forgot to put my comment here. Plot for research question 1. Now, I want to do the same thing, but for research question 2. I'm not going to rewrite all of it because that's inefficient, so I'm going to just copy paste and then change a couple things. So RQ2 now becomes RQ2 variable here. So I'll change that 1 to 2. Now our X variable is now going to be season, because we're now looking at season by viewership. So does the viewership change over the seasons? So season, and then we want viewers mean here. Now this geom point is going to stay the same. Our regression line is going to stay the same. This background removal is going to stay the same, but we do need to change these labels. So we could go season here, and then viewership maybe in general here. So if I run that, now we get our viewership by season scatter plot, and we can see the relationship there. So at this point, you should be looking at step 2. Now we want you to use these scatter plots to describe your first impressions of the correlation and regression. So things like size, direction, and shape. Now we don't have any numbers yet, and that's the point. We want to just look at these and see what do you think? What's happening here? What do you think our numbers might reflect after? And so just write in, that field, what you think's going on so far. And that's just a way to make sure you're looking at your data and thinking about it before you're running these tests. So the next thing we need to do is run our correlation. Okay, so we're going to do this for our research question 1 first, and you're going to see how simple this really is. So we're going to again create a variable, and you can see over here now we have our survivor data set and then our 2 plots variables. You don't have to save them into variables, but it's always good practice too. So RQ1 underscore core is going to be our correlation. What we're going to use is a function called core.test. Okay, and now what we want to do is put our columns specifically. So we need to select our columns. We talked about this last day, or last computer lab, but basically we can call a column using the $sign. So if I go survivor underscore data and use the $sign, it gives me all my different columns. So if I'm looking for viewers premiere, for example, now this line of code, so survivor data set is what our data is in, that's what it's called, and then within that there's different columns, and one of them is viewer premiere. And if I run this, it's just going to give me that column of data. So 15.51, if we look, viewer premiere starts off with 15.51, and you'll see it ends off with 7.75, just like our data here. So now what I've done is I've just said, okay, this column, I'm going to put that right into our core test, and then comma, what other column we want. So in this case, it's going to be finale. Okay, hopefully that's making sense. So if I run this now, I have a new variable called RQ1 core. Now I can open it and see what it looks like, but really let's just spit it out here. So if I just run this variable name, now we have all these different things. What you're interested in here is our correlation. So 0.717, so forth, is our correlation between the viewer's premiere and the viewer's finale. Now it has a lot of other things like p-values, and even though you've learned about p-values, you haven't learned about it in terms of correlation. So ignore these types of things up here. But I wanted to include them for later in case you do these correlations later or for your own research, and that might be helpful. So that's it for correlation of regression research question 1. So let's copy paste for research question 2. So now I'm going to change that to RQ2. This is RQ2, and then we have season, and then viewers mean now. Okay, so all I did was change the 2 column names and then this number here. So now if I run this, and so remember this is now looking at this data set here. So we are going to get a correlation of negative 0.9066, so forth. And again, it has all these other things. So this correlation is for season by viewership. And then this one up here that we did first is for the relationship between viewership and, premiere viewership and finale viewership. So that gets our correlations done. And if we jump back to this now, what we have is R. So we need that correlation in there now. And you could tell us things like the direction and the strength of it. Now these 2 things are based on lectures, so conceptual things. So make sure if you don't know what to put in there that you're looking at your lectures to make sure that you're doing it correctly. Now, the last thing is we want you to tell us what this means. Is there a relationship between them and what does it mean generally? So we're looking for non-statistical jargon here. So just if you're talking to a friend or your grandmother, what might it mean? Perfect. The last thing we have to do is create a regression itself. And maybe I'll jump back actually. All we're looking for is the intercept and the slope. Then we're going to put it into our equation. So we don't need too much information from a regression either. So let's do that now. So I'm going to again add my labels or my comment. So regression for RQ1. And so what I'm going to do is RQ1 underscore REG, so for regression. And then we're going to use a function called LM, linear model. So that's what our basic regression is going to use. Now, the way this works is a little bit different than what we've done so far. So far, we've just given it, okay, well, here's column 1, here's column 2. Now we need to tell it what to predict what. So the first thing we're going to put in is actually our Y variable. So for research question 1, we're actually going to see if Premiere can tell us anything about finale. So our Y variable is finale, just like we see over here. So we're going to start with finale, and then we're going to put this tilde here. Okay, so that then is asking, well, what are we trying to predict this from? So that's going to be our Premiere here. So you'll notice it's kind of in the opposite direction as the correlation. So we started with finale, then we ended with Premiere now. Okay, hopefully that's good. And we're going to run this, and that's going to give us a new variable again, RQ1 reg. Now, if I just run this, it's going to give me very little information. So if I just run this, it does actually give us our intercept and our slope. So right there is all you actually do need. So you can move on as well. But if we go summary and then put that stuff in it, or this variable name in it, it's going to give us a lot more information. So what we see is, just as we saw a moment ago, our intercept is 3.5 something. That's the same as this estimate here. And our slope is 0.81, and that's the same as this estimate here. So this row is our intercept row, and this row is our slope row. Now it does have other information, for example, a p-value again. So again, we're not going to be worrying about p-values here in this assignment, but for future, or if you do run regressions on your own data or whatnot, do note that there are p-values that you can use and t-values and so forth that you can use in the future. But for now, all we really need is this estimate and then that estimate. So that's our, again, y-intercept and our slope. So let's do the same thing for our second research question. So again, I'm going to copy paste. So I am being efficient here. So RQ2. Now, what are we predicting here? So we want to see if season number actually predicts the viewership. So here we actually have our y-axis. So if we look at this as viewership, so that is viewers underscore mean. And then our x-axis is season. Perfect. And then we got to change this to 2 as well. So again, here is our regression. We got a new variable, and there is our intercept and our slope. And then if we do the summary, we get a bit more information about all of it. But you still have your intercept and your slope right there. So now what you need to do is put those two numbers that you've chose, depending on your research question, in there. And then we want you to use one of these two equations, and you got to use the correct one, and then fill these two boxes in with the same thing, so intercept and slope. Lastly, we want you to describe the slope in words. So what does it mean? So this number over here, for example, negative 0.41, what does that mean in relation to this relationship here? So that's talking about our viewership. So what happens to our viewership? I'm going to leave that for you. Hopefully there is no questions, but if there are, ask your TA or your professor, or you can reach out to me and they can give you my information if needed. Good luck, and I hope it goes well.